You're there.
Yeah, Comcast thinks your address is invalid.
Right. Yeah, it does that a lot. I don't know what's going on. Comcast has been a problem for me.
Oh.
Sending to
Me too.
Comcast.
Yeah.
All right. I think I got it
It's
together.
Dana.
I got the right glasses on, so now I can see you guys in focus. That's nice.
Maybe you really want to take them off.
Yeah, you're right. Yeah. Put the blinders back on.
Yeah, right.
Nice.
Yeah, when the world was warm and fuzzy.
Exactly.
Or when we were.
Oh, golly. Yeah.
Well, let's see. So we might have, let's see, I can turn my volume up here so I can hear you guys a little better. I talked to Gary Geselshen yesterday. Yeah. And so he might join us. Hi, Renan.
Yeah.
And who knows, maybe we'll get Max and he'll come on here and talk about all his nice engraving stuff he did.
Yeah, that would be nice.
That's cool. Hey, Sean.
Hey, what's going on?
Partying on
Yeah,
a Saturday.
it's party time.
Cheers.
There you go. Nice.
Rene, those have to be the largest vacuum tubes I think no, they're not the biggest ones I've ever seen, but they're pretty big.
Yeah.
The size of your head.
They seem to grow here. Yeah. It's my big headphone amp.
Gosh.
Oh, okay.
I'm wearing my little headphone today, but
Yeah.
Let's see.
Yeah.
There we go.
What kind of tubes are
I
in?
used to work for a tube
It's-
manufacturer. A friend of mine used to work for a tube manufacturer, and he made some transmitting tubes, for old-fashioned transmitters that were like this big around. I mean, they were huge.
Wow.
I have some of those. These are all 6 DJ8s. There's 4 in parallel for each output side for the output part, and then there's 2 that serve as the input section. One for effects. And the headphone amp has, for effects, it has 2 controls. One is you can change the equalization to be a smiley face or a frowny face.
Huh.
And the other one is you have a tilt control, so you can
Right.
tilt the whole thing up and down. So
That could be.
Anyway.
in.
they're kind of interesting. The frowny face, smiley face came from Mackie because that's one of the things they put into their little portable speakers. And tilt control came from John Brodsky, who's anyway. You can read his blog on all that.
Yeah, but
He likes it.
probably he took from Quad and Radford in England. They did from the 70s. They used the tilt control in
Oh, yeah.
the amplifier.
Yeah, it's very old. Yes, it is very old. But he sort of resurrected it for me. Kind of said, you ought to try this. So
Yeah.
I built it in just to see.
Do you like it?
It's okay.
I was
No,
always tempted
I
to
don't-
do it.
I don't use it that much. What I do use is the smiley face, frowny face, because sometimes the frowny face accentuates the mid-range, and that's very good sometimes when you're trying to listen to the vocal part of a arrangement.
For my tilt
the smiley
control, I
face-
either use whiskey or beer.
Well, but doesn't that make everything kind of recede?
Well, after
Background.
the second bottle, everything sounds fantastic.
Yeah, exactly.
That's true.
Yeah, I become
so that
much,
becomes a
much more
smiley
easily to fool. Yes.
So
Okay.
that becomes the smiley face control.
Okay. So Tim, I see you're here. Baron asked a question earlier. He's still having trouble paying his dues. What do you think is going on here?
I'm not sure, but I can look into it now. I can leave the meeting and look into it now. Oh, are you trying to pay through PayPal, Baron?
I did try that.
Oh, you can do
Oh,
it later.
What,
Yeah, but yeah.
what
Okay,
Just so you know there's a problem. And if I can mail a check to somebody, let me know.
Yeah, you
sure.
yeah, you can work with me, Tim. I haven't paid yet, so I can get on there and try, and we could work it out on the phones. I'll let you know how it works for me, and then we can go from there.
Great. You want to do that right after the meeting?
Sure, that'd be perfect.
Okay, great. And Baron, then after Dana and I kind of work things out, I'll contact you. I think I have your email address, I'm sure, and we'll work it out. How's that? I'll make it as easy as possible for you. Okay, thanks.
Yeah,
Let us
I'll go
know.
through the ringer. Yeah.
Well, the idea is to make it as easy as possible for everybody, including you, Dana. So
Okay.
yeah.
I'm used to going through the ringer.
Uh,
Normal.
You must be
So-
married.
okay. Sorry you're having problems, everyone who might be. Yeah.
Well,
Well,
the
by the
Russians
way-
attacking our internet. There you go.
By the way, I want to remind everyone that the DIY club has no dues. So don't be sending checks. Okay?
Okay.
Yep.
Hey, Rene, now I know where all the 12AX7s in the world have gone to. But you can't find any of them. But
No, that's the DJ8s.
oh, okay.
Yeah, 12X7s you can have.
Oh, okay.
Oh my gosh. Very good. Well, I'm recording this one. I'll put, because Howard couldn't make it today. So if anybody doesn't want to be recorded, well, I guess put a face mask on or something.
Okay.
That's-
Can I ask one more question before I permanently mute myself, please? Just of Rene. I've been drooling over the preamp, the 801 preamp that Max has done, and I was just curious how the circuit topology, how is that different from the 10Y preamp? I'm just curious.
Yes, interesting. Well, the 10Y came after that, and I ran on the 10Y preamp. I ran the tubes in what you would call cathode follower mode, but of course, since it's directly heated, it's filament follower. So basically, a less than unity gain approach, and it was very difficult, I have to say, getting the noise down on that. But anyway, as you know, it works. The 801 preamp earlier actually is run in a gain mode. It has input transformers and output transformers. So let's see. So that's the main difference. So it has a little bit of gain. But the 801 can take 10 Ys, and it also was set up so that you could change the filament voltage to plug in a 300B. So it had a little flexibility to it. All right. But anyway, when I made the 10Y, I didn't have any more 801As. Max bought them all. And I think he's cornered the market out there.
Yeah, I
He went out and bought
collected.
some.
Yeah.
Yeah, there you go. So they're very hard to find now.
Yep. I even scored some ceramic base ones, actually.
Yeah.
The white RCAs.
Yeah, with
They're really
graphite
hard
plates.
to find right now. Yeah.
Yeah,
They're
With
not
graphite
finding
plates.
graphite
Yeah.
plate with there's a white ceramic base instead of the brown Mechanol, I think, or what material is that? I don't remember. Plasticky material. Instead of that, it's
Right.
Bakelite.
ceramic.
Bakelite.
Bakelite. Yeah.
Yep. So they sound pretty good.
Yeah, I sometimes swap 10Y and 801 and 801 A. So I got a whole bunch of them, probably like a dozen or more. So so anyways, so they're all fine, good sounding
you're
tubes.
fixed for life.
They have a long life, actually. I realized they're like probably 10,000 hours or something like that, or long time.
Easily, yeah.
It should last you for a couple of years.
It's gonna outlast me for sure.
Wow. So Max, you want to show us pictures of your, you emailed a couple pictures,
Oh,
maybe the rest of the group, if you have them available, I can make you into the host and you can show them.
I don't have it on computer though. I
Oh,
sent
okay.
through the phone. It was easier for me to do it over the phone yesterday. I just snapped some pictures and sent. Let me see. Actually, maybe
I wonder
can.
if I could show them,
Let me see on the phone.
because I think they
Yeah.
showed up in my email. Maybe I can show. So
Yeah. Let's see if I see some other pictures. Maybe let me see if I can find some.
yeah.
Or Max, maybe you could just carry the computer over to the unit itself and show us.
I
directly.
tried it, but it
Oh.
just doesn't do justice. It's
Oh,
worse
okay.
phone.
Okay.
With the camera on the computer.
Yeah,
it
I could
wasn't
show.
showing.
I can show a picture here.
Yeah.
Let's see here. Oh, share 1%, multiple. What's happening? If I can remember how to do it, God, I tell you.
Actually, that picture doesn't do much justice either because it doesn't show the colors. Rene, what I did, I went to your website and basically snap your logo and the text. And I noticed you use some kind of a nice green color. So I bought some green nail polish. And yeah, the Jagger audio at the bottom and the emblem actually is green, but it shows like blackish over here. It's a very nice green, matches your website color. So, and then the attenuation input, balance dB and attenuation dB are also same green at the top, and the rest are all black. So the way I did this, basically, I dismantled the front panel and measured it, all that stuff. And with the CNC, I have a software. I got this cheap CNC. It's about $250 or so through Amazon during the holidays time in the past. So I started learning about this, and I got the hang of it. So I just modeled this on the CNC software, one for the top plate input markings, another one for the front panel. So I have two files I prepared, and I can. What I did was, if you scroll up, Dana, on the preamp, it takes a long time with the tiny little bits to engrave this thing because I'm going through very minor passes, like 0.01 millimeter per pass.
Yeah.
So, and it goes for hours. So I basically set it up before I go to sleep, and it goes overnight. And then in the morning, if everything goes well, I actually go to check it. So, and if anything wrong, or anything bit broke, for example, I actually reload the bit and rerun the program from the place that it left. So, or the bit broke. So some sections I did multiple times because it wasn't really deep enough. But yeah, it turned out okay in the end. Brass is kind of harder, actually. I was testing with aluminum before. I found aluminum was easier. Even though people claim brass is easier to machine, actually, I found aluminum to be softer on those tiny little bits. So bits-wise, it's like these kind of bits. I can show you.
Yeah.
Like
here, I'll let you. There you go.
Well, I mean, it's. Let me see if I can.
Oh yeah.
This is a bit, for example. It looks like this. It's a. I mean, these are really fragile bits. At the tip, it's very thin.
Wow.
And this is actually snap bit. At the tip, it is already broken. So, I mean, let me see if I can put some background here. You can see maybe.
Yeah, maybe back it up about 2 inches.
Like this.
Yeah.
This is a broken bit tip. I mean, even though it's
wow,
broken,
it's sharper than that. Wow.
Sharp. This is super sharp, and it comes in like little boxes, like these. You buy like a package.
Yeah, you need a package.
Yeah.
And as I go through the bits, I mark them that are broken. So like I change their orientation to indicate myself which ones are broken. So then I load the ones that are not broken. Let me pull a new one so you can see the difference. It is super sharp. But the thing is, the moment it touches the surface, the tip just breaks. So these are really hard to manage. So I winged it a little bit, and I did multiple passes. Even with the broken bits, I managed to do it. This is a brand new bit with a sharp tip on it.
Wow, that's shiny. That's amazing.
So it's a carbide, so for
got a mirror
metal.
finish,
It
man.
used to be carbide tip. So it's kind of fun, actually. I learned a lot of this. I didn't know anything about this when I started a couple of months ago. So researched a bit and found the rates. For the CNC, there are things like feed rate and the plunge rate. So how fast you go to the surface and how fast you actually go around your machining that you need to do. So I play with different things. I run some test plates and stuff. And yeah, so I said, well, let me just do Rene's preamp that I got from him first. So I just tried on the back side of the plate first. It turned out okay. So then I got confidence and turned it to the front, and then I started doing it. So I started last week, I think, and then I just finished it right before this. So, and interestingly, for Phil, I was researching, and then I found this. There's a community about the Glock. The people have guns and stuff. They have the markings on them, engraved markings. So there's like a big followers about that, filling that with nail polish. So I found about the nail polish method. So I did the same thing with this one. After I engraved it, I basically applied the nail polish and this with acetone, remove it a little bit, sand it down just a little bit. So it became like what I showed you in the picture. So I'm pretty happy about it. So I think I'll do the same thing with other things that I have that don't have many markings on them.
Yeah, most nail polish is just a nitrocellulose lacquer, I believe.
It turns out pretty strong, actually. So it doesn't, once it sets, it's actually a very nice material. It's depending on the polish that you get. I got shiny ones, I think. So the black shiny. So when you actually apply it and then when you wipe it off, it still preserves its shine. So
yeah, and you can use acetone to clean up. So
yeah. So if you guys have, I have some CNC machine now. So as long as you can get the front plate to me with some design ideas, it's fun. So
wow. So what kind of file you got to send it? Do you generate a tool path or?
Yeah, let me show you actually. Just a second. Maybe I can show you.
I was trying to think of what kind of file I would give you.
Let me. The process is kind of. Let me see.
Because it's just like a.
Yeah, I'll take one of those.
Yeah,
it's just a background.
Can you mill one of those out?
I ain't machined it.
Just bring a solid block of unobtainium and he'll mill one of those out for you.
Yeah.
I used to have one of those.
Yeah.
The background, this.
Oh.
So
The
this is the software I use. I just downloaded it. It's a free software called Carbide 3D.
Oh, cool.
And, you probably have come across this, Dana, since you're into 3D printing. Some people use similar software. So you design it here. I designed let me see. I designed it so that it's actually vertical, because my CNC machine, this vertical size, this thing, is the top of the CNC machine size.
Okay.
So it has to fit into this area. Whatever I'm engraving or routing out, it needs to be in this area. So I make sure of it. If it doesn't fit, I can do in sections. So basically, there's a larger piece than this, longer. I can feed the first half first, and then dismantle it after I'm done with it. I actually shift it upwards, so my origin stays in focus. This is the origin here at the bottom. And then you basically design your thing. So I measured it on the front panel, what the holes are. So these were roughly where the dials were reaching. And this is what the power switch was and all that. So I said, well, let me put some emblem somewhere. Where do I put it? I couldn't put it up here as the normal usual spot. I think Rene has the EIR amplifiers or preamps. So I remember they had something like this off some other place. So I said, well, let me put it here. So I put the emblem here, and I put the rest of the things over here. And you can zoom in and stuff. So one thing about this, if you're going to do any kind of engraving, you run into an issue with fonts. There are lots of fonts on your computer, but when you use them in here, they're all outline fonts. What this means, when you write a character, it's gonna write outlines for the character, both inside and outside. So the whole, you see a solid piece of character, but it's not solid. There's an outline and you know, basically surrounding all the perimeter of the
Right.
character. To get around this, I found this font, a single line font, which is used for engraving. So I use another software called Inkspace. So here, there's a software called Inkscape, I think this one, Inkscape.
Hmm.
So with this one, you basically create a text. Let me just show you here, for example. Let me just enlarge this a bit.
Oh, and then you can paste it.
So what you do, so this is a test text. This is not, and then you can set the character size and all that stuff. This is pretty powerful tool if you're into engraving or in general 3D modelings and stuff. So this Inkscape, I recommend this software. And here, this is an outline font, even though sans serif and all that stuff. You see the perimeter of the font. The engraving basically tries to follow the perimeter of the font instead of going straight through the font. So what you do in this software, there is this thing called extensions. You come here in the text, there's a, probably some of you remember this from 1960s or something, 50s, 60s. This guy called Hershey came up with Rust, you know, the vector font that can be used as a single line font. So let me just do this now. See, when I apply, I'll take a look at, see, it changed it to what's called a single line font. So now the engraving machine follows this vector content to trace this onto the engraving on the CNC machine. Because CNC machine follows XY coordinates and Z. So with the XY, you can actually just go follow these lines. You know, it starts from here, follows through there, and then from here follows there, and then E, it follows this path, and from corner to corner, it follows like this. You see. So to make this even smoother, when I did a test like this, I said, well, even though it's a small font, it looks kind of jaggedy a little bit. So I said, okay, there must be a way to smoothen this just a little bit. So, and I found in this software, you can actually do that too. So you come over here.
Wow.
Like you click on this thing here. See this T, like E. I can make it a bit larger maybe.
And you can put splines in.
So now you do this, and then you mark this area here, like this, and then there's a smoothing function here. Now look at it. It's smoothened it a little bit. So when you actually shrink this font to the size of the engraving on this faceplate, then it really looks smooth. So it doesn't have any jaggedness. So here, and I do this section by section like this. So for this one, S, it's a lot easier because it's a single thing. So I just mark everything and then see it smoothened it a little bit. With T, it's kind of tricky. I click, if you select more than enough, then it actually messes up the shape of the font. But with this, if you select the right nodes, see it actually smoothened that too. So then once I'm happy with this, basically on this software, I write all the words, all the characters that I need on the other software, right? So then basically once I'm done with this, I say, okay, save. Let me say drawing like this. Now this is saved, right? So I go to my software here on this one. Let's say I want to put this over here. So I come here in the design stage, there's an import. And this drawing that I just created, I just import this. It probably imported somewhere. There you go at the bottom. See, I can put it here. Then what you do, well, orientation is off, right? So you just change this one to be well, when you import it, it's actually all individual little bits of vectors. So when you click on this, it's one vector, another one vector here. E has a single vector, S is a single vector, but T consists of two vectors. So it comes down like this, and another one, the T cross, right? So you group things together. It's a bit tedious process, but you group things together like this. Now it's grouped. I can rotate this around. So I rotate this a 90 degree. Now it's actually set, right? And let's say I want to have this one maybe larger. I had 6 fonts, but I can actually make it larger. I can scale it to, let's say, 1.5 times bigger. There you go. So now the text is there. You need to create what you call the toolpath data. So here, I come over here in the toolpaths. You create a contour toolpath. So I define my own tools in the software. It went some other place. Where did it go? Edit. Okay, here. But I have those, basically, I created a V-bit, 20 degree V-bit, the sharp bit for the ones that I have. And I set the cutting parameters for it. How fast do you go plunge rate and how fast you go across each character. These are millimeters per minute. And the RPM of the motor that you're actually using for carving out things. So then it is set. And then here, the other thing you define is the depth per pass, because you cannot just go do one at a time. This is a mini machine, so with a very fragile tip bit, right? So you basically go minuscule amount for each pass, 0.01 millimeter in this case. And you make basically, the machine just makes multiple passes as needed. For the depth you specify, so from the 0 depth at the top, all the way down to, for example, I want to have this character to be 0.2 millimeter deep, and I want it to be on center, no offset, and then I make a name for it. So this is test path. So then I say, okay. Now it added at the end. If I go here and enable this, and then when I show the simulation, I think I also selected balance levels here too. So let me disable this simulation. Disable. In the test path, see, it showed me what it's going to do if I actually send this code to the CNC machine. It's going to follow these paths. It's going to basically carve out test in there. So then I save what's called the G code. Under here, I basically say test path. And then the CNC machine takes these G code files. You can load it to the CNC machine. And CNC machine has a software called this Garble control, this thing here. So when you open, actually, maybe this one here. This one. See, it loads up like this. So as long as you are connected to your CNC machine, then basically you just go and set up your CNC. There's a setup email for CNC machine. You need to zero out the coordinates and all that, set your stock correctly. Once you have everything ready, then you're going to see the bit location on this diagram where it is located, and you just basically say, go. So then it actually goes and basically just starts engraving stuff. So sometimes the surface material is not so even. So what you do, since the surface is not even, and the CNC machine doesn't know anything about it, right? So it just follows the path at a certain height. If your surface varies in height, very minuscule amounts, because remember we're going only 0.2 millimeter here, fraction of a millimeter. So if the surface is not completely level, if there are bumps and stuff that you don't even see with your eye, it's going to actually have shallow spots or missed spots. So based on those, there's a thing called height mapping. So you can run on the CNC machine prior to what you do, a height mapping, and it actually maps out the surface with some kind of a height references compared to reference point that you set. So when you set go, it actually takes that into account and then just follows the contours of your surface. So with that, if you even have a curved surface, you can even engrave on the curved surface too. So this is especially useful if you have a PCB. People use this machine for PCB purposes too. You can, instead of doing the chemical process on the PCB, you can actually just carve out the lines to leave the traces in place, and then you can actually do that. And and interesting.
Will it work on soft surfaces?
Yeah, woods and stuff. I mean, most people
What about
use,
like, say you're making a power cord, and the sleeves on the end of the power cord, you want to put a logo on that sleeves.
Ooh.
I think so. As long as it is not super soft, like too much of a give to it. As long as there's some kind of substance to it. These bits are very sharp.
I'm thinking about that shrink stuff, that you put on.
Heat shrink should work. Yeah, I didn't try heat shrink, but it definitely should work. Heat shrink will work. Yep.
And can you put different colors on it, or do you?
Well, the color, you just basically, I paint using the nail polish. So
just
you
rub
can
it
do
in
that.
and wipe it off.
Yeah. But most people, I didn't get the laser version. There's a laser attachment you can put also.
Oh, okay.
For that, laser might be more suitable because laser actually marks with a black marking or whatever the laser attraction.
How are we going to be able to use yours without a laser thing? You got to go buy a laser thing for us.
Yeah. Yeah, well, I wasn't sure about laser things and stuff in the garage, but yeah, I mean, I said, well, the engraving is enough for what I needed to do, so I decided to engrave. But
Oh yeah.
Well, I think it looks great. I think it looks really, really professional and looks really good.
Thanks. Yeah, it's very fun. I mean, I learned a lot. As you might notice, I go deep into stuff when I start. So I learned a lot of things on this CNC thing. It's a limited machine. It's called a hobby machine for $250. I mean, I can share what it is. So let me just share what it looks like. This is what I got here. So it's very small. I mean, it's like by default it comes this size, but there's an extension kit. So it's like a base like this, and they send you, if you buy the extension kit, the top surface stays the same, but these rails at the bottom, they send you longer pieces. So mine is a bit longer than this default one. But yeah, so basically you can find more about it over here. There are different versions of it and all that. So cheaper, a bit more.
I still see a reasonable price for it. I mean, it's not too expensive. It's not crazy expensive.
Yeah, I mean, for what I needed to do, and I wanted to have flexibility. I didn't want to go to a place all the time as I revise things and stuff. And with this one, I can just do whatever I want anytime I want. So
yeah. Well, it makes Rene's stuff look professional. Makes it look like he's a legitimate pro out there.
It adds some touch, I think.
What the hell is that in the background, Rene?
That's my headphone amp.
Oh,
with all the huge tubes.
Now, yeah, lots of 6D-J8s. You're one of your favorite tubes.
The main amplifier is outside the house.
It looks bigger than what it was, though. I mean, I thought it was a power amp or something.
It's much bigger. That's about 9 inches across there.
It's not the same.
It looks huge there, like some big tube amp.
Yeah.
You have to take the right drugs for it to look like that.
So what are you guys have been doing?
Hey.
Any other interesting projects?
I cut some holes this morning.
Wow.
Nice.
Router or?
Yes, with my router. I got 3 holes cut. I have the 4th one to cut. I'm back on it. It's for Terry's open baffle project, so I'm back on that again. Finally,
Okay.
finally.
So what kind of woods? Is it like
drivers are you using?
yeah? Tell us more detail.
Well, hold on, I'll go grab it.
Oh, there you go.
So
There you
Max,
go.
how's your speaker coming along?
Which one? Sorry.
Your speaker you work on where you can slide the drivers up and down.
Oh, it's sitting in the basement. It's already done. I'm actually thinking about removing the amplifiers because I put the amplifiers into the speaker. I had like 6 amplifiers in it. So
It's all class D amps.
yeah, all ICE amplifiers. They're like two times 500 watts per channel. Another one for 1,000 watts. So each one has about 2,000 watts of power. But I didn't want to put an enclosure on it, so I'm just thinking about removing them and then putting separate enclosures and plugging them that way. Still active
Right.
configuration. Yeah.
Are you familiar with Key, the speaker manufacturer? KII?
Yeah. Well, we tried to get them to us, but they couldn't make it, I guess. Yeah.
You know, because they do a separate amp for each driver too in their speaker system.
Yeah.
And I heard it at Rocky Mountain. I thought it was one of the best speakers I heard at Rocky Mountain.
A lot more flexible, my experience. I never built one with the built-in crossovers like you guys have been doing. But I started with this one. It gave me a lot of flexibility. So see what Dave has up there.
Oh, yeah. Oh, yeah. So I've been working on this mock-up for Tim. And so this is the upper half. So it's got this volt 3-inch mid-range. And then the, what's the name? I can't think of what the brand of the air motion transformer tweeter. But
Is that the Mundorf?
Mundorf, thank you. That's good when people, see, this is why we need a group. So between us, we can remember these things. And let's see. So oh yeah, there we can kind of see it. So I put a little board here and here to make it so it stand on its own. And then yeah, I got you can see the big ass magnet on here and the Mundorf mounted from the back. And, so yeah, so I was doing some measurements of that today, and I can go through those, but we'll let Dave show us his first.
Okay. Now, can everybody see that kind of?
Yeah.
Okay, so I've got one hole cut out with a recess on it for the flush mount. And I got the flush mount hole cut for the other one. I still have to cut the through hole. And it's got quite a thick mounting flange. So there's not a lot of wood left on there. So I've got a reinforcement doubler for the back side I also cut out. So that will go on the back. Oak is heavy. So that'll just go right over the back. I'll fasten that on the back and make it'll be about 7/8 of an inch thick there. Wow. Plenty of extra strength there. So, yeah, it turned out just a happy accident. I came across this piece of oak, salvaged it off of an old cabinet. It wasn't being used anymore. And the dimensions on it were just exactly the right size. When I cut it in half, I'll have the 2 baffles that I need for Terry's open baffle project. and it's solid oak too. So it's, I just got done sanding it this morning too. It had a bunch of flower pot stains on it.
Yeah.
But I think I got most of it out. So anyway, that's the extent of my audio work this morning.
So that's that fancy distressed wood you get out at farms and whatnot, right?
Yeah.
It's I sanded all that off. Unfortunately, it doesn't look distressed anymore. So
Nice.
I guess another project I worked on this week while I'm on. Maybe you,
Yeah.
can you see that over there? I've got a CD rotisserie.
Cool.
Friend of mine gave it to me. A friend of his was a carpenter and made it for him. And you can see it's got 4 sides on it. You can stack CDs in there. The problem that he had with it was I've added spacers, so I've got 3 different sections you can see. He didn't have those spacers for the 2 top sections. So by the time you stacked an entire stack of CDs on there, you couldn't get the bottom ones out. It was so heavy. So that was my other audio project this week. I've started getting back into the wood shop a little bit this week. I made 16 little spacers and I couldn't get my drill in there, so I had to fiddle around with the side of a hammerhead and tap in a nail and back it out, and I had to screw in all the screws with a little 1/4-inch ratchet. It took me 3 hours to put those little pieces in.
Hey, Dave?
Yes.
Wouldn't it have been a little bit easier if you had stacked them vertically instead of horizontally?
Could have been, but that would have been 5 times as many. It's cut this way. If you put them in the other way, they stick out way too far.
Oh, really? Okay.
It's set up with the angle that the spacers are set in there. The CD case sits just about a 1/4-inch out when you stack it. Yeah.
Okay.
It was built that way before I got it. So
Okay.
not everything was thought out really well. I'm just modifying what I had. The other thing that it has, let's see. The other thing that was kind of cool about it was it's got lights.
Oh, wow. Nice. You can see.
You can build
lights coming up off the floor. But that presented a problem too, because the lights are so bright. When you're leaning up close enough to look at the CDs, it shines right in your eyes. So
Dave,
yeah.
what is that speaker in the corner there?
Which one? Oh,
It's to the right.
that one?
Oh, yeah, that one.
Okay, that's my 3-way that I've been working on for a year now.
Oh, yeah, I see. Okay.
So I got the crossovers broken up into 4 different sections. Trying to figure out where to put them.
Okay.
I still have to finish those cabinets. So anyway, back to the lights on this little case here.
Right.
I took some PVC pipe and chopped it up a little bit.
Wow.
See if that could make it work a little better. Stick them in there.
Very nice.
And it seems to shroud the light a little bit away from your eyes, and it kind of just reflects it up the edge of the CDs. It helps a little bit, but it's still not ideal.
Is there any way you can put those LED strips in there, or there's no room for them?
Put a what in there?
LED strips. They got those very cheap LED strips these days.
Oh,
LED
I could.
strip lights along the perimeter of inside.
Yeah, the problem with that is the inner section rotates. The lights are mounted in a fixed base.
Oh, I see.
Oh.
And then this just rotates like a lazy Susan.
Ah, yep.
So the lights are down in here in the base. Like I said, it was somebody else built it, and I'm just trying to modify improve on what's there, what I can do. So a lamp on the side would work really well, I think.
Easier.
It's kind of cool. It'll hold over 200 CDs though.
Wow.
So
Great.
anyway,
Oh, that's cool.
free
Nice.
is free.
Oh, Sean is here. Sean, do you have any updates on your stuff? You had the LDR. I was starting to read the LDR volume controls and stuff. So how do you like it so far?
I like it. Had it for quite a while now. The light dependent resistor volume control. Yeah. I'm using a Tortuga Audio. It's basically a kit. You can buy a finished preamp from them, but I bought the kit because I put it in my own. Well, Rene built me a crossover basically, and I wanted to put it inside the same box. So I can turn the camera around and show you guys what that looks like. The dog gets out of the way. But, I also just bought the rack for that it's sitting on right now. It's Pangea audio rack. It's pretty cheap. It's like $250 off Audio Advisor. Works nicely. The shelves are just MDF. I put some better shelves on it one of these days. But yeah, I don't have a garage right now, so I don't have anywhere to build stuff at the moment. So I'm thinking about getting a shed or something, putting that in the backyard, and I could actually make stuff. But other stuff I've been doing is just playing around with capacitors. I modified my Hollow's May DAC. I just tried some different caps in it recently. Ended up with Mundorf silver gold oil caps in there.
But what did they have originally? They had Mundorf too, no? Mayday?
Yeah, they're not. They put their own shrink wrap on them, and I took the shrink wrap off of one of them to try and figure out what it was, and didn't have any marking on it. But from what I could tell, it's like the lowest end Mundorf. That's what it looks like to me.
No.
But it's just a guess. But the reason why, I mean, it sounds really good the way it comes, but I just wanted to see if I can improve on it. I thought it was a little soft on the top end, so I ended up playing around with a few different caps. I'm pretty happy with it now, though.
Do they have the different versions of it also, like their other ones?
They have, yeah, they do have. The version I have is the level 3, which is the highest level version.
Well, even that didn't have the caps that you wanted, huh? Wow.
Right. Yeah.
Wow. You will think for their price they will include the best, but anyways.
Well, that's really never the case. I mean, they want you to think that's the case, but it's not the case. They still don't use the highest end, or at least expensive stuff, but you know, they tune it the way they want to tune it.
Yeah. Are they the caps for the power supply, or what are they for?
I believe they're in the power supply. Because it's not capacitor coupled output, so I believe it's, but I don't know for sure. But I'm pretty sure they're in the power supply, kind of probably towards the end of it before the audio stage. But I don't know.
Nice. How do you like it so far? You had the Mola. What was the Mola, or what was the? You had the other one, right?
The Tamaki, yeah, the Mola. I had that for like a month. It was really good sounding, but for some reason, it bothered me like physically, made me kind of I don't know, it's hard to explain. It's basically made me not want to listen to music after a while. It was, I guess, fatiguing, I guess you could say. So I ended up having to sell it. The funny thing is, it sounded really good, but I just couldn't stand it anymore, so I sold it. It doesn't make any sense, I know, but that was my experience with it.
Yeah, it's kind of like a beautiful girl. You want to get rid of her as soon as you can.
Yeah. Depends on the personality, though. I mean. Month was long enough.
Hey, Jay, is that a new dog, or you had a cat before? No. Oh, you're on the mute. Let's see.
I muted him.
Oh, you did? Oh, sorry.
Well, let's see. We'll try and unmute him. I think he has to unmute. Where is he? I could send him an unmute request. I don't know if I can actually unmute him.
Oh. Nice.
Looks like he's working on it.
I thought he had a
You got
cat
me
before.
now?
Oh, yeah,
we got you.
Yeah. Jagger's and the cat are going to be 16 this spring.
Wow.
So I got them both when they're little.
Nice.
And he's hanging in there. You know?
That's cool.
Great.
Good.
Boy.
Nice.
Yeah. There's Anibal. How are you doing today?
Good. But after seeing what they did with those this tube amplifier and engraving, I will not show you what I was doing.
Sure, come on. Let's see what you got.
No. I was reading about the non-oversampling DACs, and I got interested last month, and I purchased some board on eBay with the TDA 1541, the converter, and I just yesterday I finished. I'm doing some mods. I put the board inside, and as you can see, my mods. I put some constant current to fix the offset of the DAC. And I'm trying. I'm a big fan of the transient response of the filter. So I modified the filters and I did a Gauss alignment with some caps, polypropylene, and I'm not happy yet with the sound. I'm still playing with that.
Wow.
But my way of working is just one change at the time and listening, so I can evaluate. And the measurement, I have a small AP here at home, and the noise floor dropped a lot. I changed the standard operational amplifiers that this equipment had for some OPA Burr Brown that I have all stock. Having the filter change from the standard Butterworth that it have to this new alignment, improve the noise on the top end a lot. So, but it's just fresh from the oven because I finished it yesterday. I'm still listening to that.
So, but which DAC was this? You said DDA?
The DAC is, the board was designed by a forum in Netherlands. It's the 10th anniversary, and the IC is the last generation of Philips multi-bit.
Oh, I see. Okay.
Is the TDA 1541.
Oh, right. TDA 1541. Right.
Yeah. So I was willing to give it a try, and listen how it works. And it has more air and more the music breath more than my topping DAC that I was using lately.
Nice.
But I will keep on playing.
Yeah.
The other thing that I will recommend you, I start going frequently to the Goodwill, I got some Mission speakers, small speakers for my desk. They
Oh.
are fantastic, and I
Oh.
pay $20.
These are made by Mission?
Yes, the
okay.
original.
That's the British company,
Yes.
right?
Yes.
And the size of them are what size?
Oh, let me see. Let me see if I can change the camera. I don't know. What I have it wired. Just a second.
Oh, those are nice.
Oh, okay.
Small.
Beautiful.
Right.
Okay. It's two-way bass reflex. They have a metal dome.
Very
They
nice.
put the tweeter down.
Yeah. Cool.
The woofer is aluminum, and the dome is silk, I think.
And,
I didn't measure yet because I'm pretty sure that will change the crossover, but
Right.
I got last week and I'm pretty
But
happy with this.
so they're not active speakers, right?
No.
Okay, so you're driving them at some amplifier of yours.
Yeah, not yet, I should say.
Okay.
I'm driving with the other thing that I did time ago and recently, I made the John Linsley Hood, the 1969 amp, Class A, 5 watts, 7 watts, for my desk, and it sounds good too.
Wow.
So because I'm spending a lot of time sitting in this desk, now I'm playing with small systems.
Yeah. Good idea.
Oh, that's awesome.
Nice.
I got a question for you tech guys. Can you hear me?
Yeah, I was just going to say hi. Welcome to Gary. Gary just joined us, it looked like.
Yeah, hi, Gary.
Great.
I'm having a problem with my home sharing. It cut off last night, and Apple won't let me use it anymore. And they're saying I have to upgrade my software, which I can't do. My system's too old, and it seems like Apple keeps doing that to me. First, they cut me off from the iTunes store, saying I didn't have enough. I didn't have an upgraded system to do that because I couldn't buy from Apple Store anymore. And then now they stopped me from using my home sharing, which I don't see how they could do that. It should be a self-contained unit, I would think, with my iPad and my computer talking to each other. It's really frustrating that I can't use it. I'm kind of pissed off about it, to be honest. I'm not sure how to fix it. Before in the past, I had trouble with it. They'd automatically send me a code on my phone, and I punch the code in, and it would work. But now they won't even send me the code anymore. And it seems like kind of funny that it seems to coincide with everybody getting their stimulus checks. So it's kind of like you're trying to fuck you into buying a new computer system, you know. I don't know. It's just really, really frustrating, and I'm tired of dealing.
Can't you put on the new operating system on the old computer? You have to buy a new computer?
Well, my computer's a 2006.
Oh,
and
that's brand new.
It's outdated and no longer supported by Apple.
Right.
But
I guess your best bet would be to call the geniuses at the Genius Bar, you know.
Right.
Well, what kind of computer is it?
It's a Apple Pro Tower.
Mac Pro Tower?
Yeah.
2006?
Yes.
So what's the highest operating system that it has?
that's what I was asking. Why not upgrade the operating system?
Well, I don't think I can. I don't think it will allow it. It won't take.
That's the Apple trick for you. They don't allow you to upgrade OS. No.
Why don't?
Well, the thing is, I stopped buying Apple because of that reason. Actually, I bought like iPads and stuff. They stopped working. They shouldn't be stopping working.
Yep.
If it stops working, then it's not a good model. So.
Yeah, so it's like they do it on purpose, so you have to buy new equipment all the time.
Well,
you know?
what's the operating system on it currently?
I think it's Lion.
Lion. And what do you need for this, your system to work actually? What are they saying you have to upgrade it to?
I'm not sure. I'm not very tech savvy, so I'm not sure what they
Probably
want.
the latest operating system.
Well, it didn't. It wasn't the latest one. It was just a one or two ahead of where I have now, I think. But like I say, it's no longer supported, and so my computer won't take it.
Yeah.
I haven't called Apple to see if they can fix this problem for me or not. It seems to me that they shouldn't have anything to do with it. Because it's a self-contained system in my computer. My music's in my computer. I have my iPad. They're talking to each other. Why would Apple get involved in that? It seems weird that they can control that and stop you from using it.
A model that actually is able to hold with a patch, even the latest OS, is available on Craigslist for $400. If you were willing to do an outlay, it'll take Lion and it'll take every operating system, including the present one, which is way ahead. Craigslist is actually a really good place because it's a lot cheaper than eBay.
Okay.
And so, if you send me your email, I can help you with this because this is my sort of forte.
Oh, okay.
I'm actually upgrading a music producer's Mac Pro Tower at the moment. It's been a long-term project. So I'm quite familiar with the operating systems and what's possible. I'd have to look at it, but even the 2006 with a patch may have further upgrade capacity than Lion. So the key piece is, what operating system is Apple requiring? Or if you can send me some details on what your internal music system is and what, and then I can look at what it needs. But I'm very sure that this 2009 Mac Pro, which is 2 generations ahead of yours, there was the history is that there's a cottage industry around it because Apple didn't come out with towers for many years. So the people who were needing upgrades came up with a cottage industry, including very intrepid patches that allows the people to upgrade far beyond what Apple says. Right.
Okay.
So this 2009 Mac Pro is incredibly versatile, and I have seen them go for as low as $400 on Craigslist.
Okay.
So if you want to be in touch with me, I can help you with this. Since this is DIY, and the original premise was we have to help each other or need to help each other. So I'm happy to do that.
Yeah, that sounds good. I definitely want to do that.
Yeah.
Cool. That's awesome, Siddhartha. Wow.
Yeah. How do I get in touch?
Look at the email list. He's on there. What's your email? If you look at the meeting invite, there's a list. I just include everybody's email in there, so you should be able to see
JB Hope at Hotmail.
Yeah.
JB. Okay.
JB Hope.
Okay. Yeah. Jay, if you wanna, if I take a moment, is it okay for me to give you? I guess I can send it on email. I'll send you my phone number.
Okay.
Then we can be more. It'll be more cumbersome to do email versus talking directly.
Yeah. Sounds good.
Cool.
Thank you. Thanks, guys.
You're welcome. Yeah.
Yeah.
I'll
cool.
be able to. Yeah.
So Gary, how are you doing today? Thanks for joining us.
I'm doing well, thank you.
Neat.
Dan and I had a long conversation a couple days ago, so I thought I'd check in. I do enough Zoom that I don't do a lot of it, but I do enough of it that I don't usually look forward to it for fun on Saturday, but what the hell.
Hey, I was thinking, so did you want to show people a picture of your 3D printed front baffle you did with your speaker last year? I don't know if anybody's seen that.
I'll take you on a trip across the room here. Well, I've set them on the floor right now.
Sure.
I just took them. I think I'm going to be onto something here. Hang on. I'll do it upside down, but they're symmetric, so you won't know the difference.
We're upside down most of the time anyway. Look at that.
Wow.
So it's basically this. Let me pull a box out of here a little bit. I built these MTMs that have a 8-inch passive radiator on each side.
Oh, that's good.
And the front of it has two of our Vanuatu 5¼ inch woofers. And in the middle, I put a tweeter that was it's a Peerless aluminum dome tweeter that you can buy for somewhere between 10 and 25 bucks, depending if it's on sale or not. And I built a waveguide. The whole front baffle covers up the drivers and then has a waveguide for the tweeter. And I took the original tweeter faceplate off and made it so I could attach it to the waveguide. And I tried a couple different ideas, waveguides, then had them print that whole damn front thing. And I built a set of them, and I've been running them for the past year with a stack of electronics. I got a couple of old AdCom amps and a D2 or a mini DSP board as a crossover, and I really like the sound of them. But it's slave to this big stack of electronics that you can't get rid of. And I've been wanting to be able. We can't actually reprogram our amps, the Vanuatu amps. The DSP code and stuff is put them in at the factory, and we've never been able to change it without getting them to actually make a different version of the code. I got some instructions from them on how to actually reprogram it myself a long time ago, and I couldn't get it to work. And I spent a little bit of time on it yesterday, and I'm very hopeful. I think I'm going to be able to reprogram it. So my intent is to take one of our T1E amps and put in those boxes to get rid of the stack of electronics, and then I can let somebody else try them out and see what they think, just to get feedback on them and see if other people like them. But I'm really, really happy with them. They sound terrific to me, and it was fun building them. And I built that. Dana was here the day that 3D part came in the mail. The two of those things cost $400 to have printed. They were $200 a piece, but they're a big part. I mean, things are 17 inches tall or something like that. And putting it together was a pain in the ass. I originally thought that could be like a production design, but it's way too hard to assemble. But it sounds great and look kind of cool. So
Hey, it looks beautiful. Oh my gosh. Yeah. Yeah, it looks amazing.
No, I don't see any screw holes or any kind of thing in the front. Are they like back mounted or?
Yeah.
Oh,
The reason they were a pain in the ass to put together is there's standoffs, 3D printed into the back of the thing and screwed into the baffle from behind. And part of what I was trying to do is hide the woofer frames. Our woofer frames have screw mounts from the front, and I've always thought they were kind of ugly. So I had this theory that I was going to hide the woofer frames for better aesthetics, and then build the waveguide into it at the same time. And it works fine for a one-off, but I think from a production point of view, it would be expensive to implement and kind of hard to put together. And there's always a possibility of it rattling and making noises and crap that's not good. You want little clearances, but that gives a possibility for things to vibrate and make noise. And so I don't think it was a very good production design, but it was a kind of a fun project, and I like the outcome. I just want to make it enough that I can use them without the stack of electronics in the room and let other people play with them, see what they think. So I don't think we're ever going to productionize it because the evidence is people don't want to pay more for powered speakers, at least from the stuff that we make. So we sell a lot more of our little one than our bigger one, which the big one's not very big. So
couldn't you put the screws in from the front and put them in deep enough that you could have a rubber goodie, a receptacle for the grill over the top of it?
Yeah, but you'd always know that there was something there, right? The idea of having it all be one piece is you don't have any seams or any joints or anything.
Oh, okay.
Everything's hidden, and all you see is this one nice piece. And it works okay. It should be kind of a pain to build. It's not that we couldn't do it, but it would be an expensive mold to have made. And if you look at gobs and gobs of commercial speakers, a pretty standard thing for hiding screws is people put trim rings around them.
Yeah.
A small band around the outside that kind of dresses it up and hides the screws, and that's kind of the more normal thing to do. So
Sure. Okay.
Or the British design don't care about it. They just put gazillions of screws in the front.
yeah,
Like the Chartwells, and I was checking the Chartwell speakers recently. Sorry, they had a whole bunch of screws in the front.
well,
I think they do that intentionally so
Is
that
it?
you look that it's more bespoke.
Rene's got Rene's got the Harbeths, and Harbeths is famous for that, right? They've got screws in the front, and they look great.
Do they? I don't know.
Oh yeah.
Renan, do they have? I don't remember
There's
yours.
screws in the front.
Oh, is it? Okay.
Yeah.
Yeah, that's just part of their look.
Part of their look.
Always
Yeah, well, it's because they came from a pro audio state, and they just never quite got away from that. And
Right.
I think people expect it anymore. So
Yeah. It's part of their look. So there's got to be something behind there because there's a screw. So there's got to be something inside there.
I've been screwed before, and there was nothing there. Nobody got anything out of that one.
There we go. That's what she said.
Yeah.
I'm sorry, Dan, but that's not what you want her saying.
We went right off the rails on that one.
Nobody got anything out of that one.
I'll have to edit that out. Yeah.
Yes. Oh my God, are we being recorded?
Yeah. Oh yeah.
What a good.
Harry, it's all your fault.
I apologize.
We'll get canceled later.
Oh, I'm sorry. I'll watch my language.
It's all good.
Let us see your T-shirt, Terry. What do you wear today?
Yeah.
I always wonder about your T-shirt, what it says. You have always some funnies in the front. No,
Okay.
not
Oh,
this
me?
time.
You talking
No, I
about
mean,
me?
Oh, sorry, Terry.
Terry. Oh, Terry.
You too, actually, but Terry always has some.
What's
slogan
Terry
or-
say?
I think it says nobody got anything out of that one.
No.
So Dana, tell us about what you've been doing with your speakers.
Sure.
Oh, I see. Oh, Boston.
Let's see.
Sure. Let's see. I'll
That's cool.
we'll deep dive. Let's see. I can share screen and bore you all to tears. This is going to be great. Let's see. Which one is it? It's this one. I can figure this out. There we go. Hopefully you see a speaker with a microphone in front of it.
Yeah.
Now, can I drive this? Okay, this is curious. Can I actually drive this screen? There we go. Okay, so this, basically today I was making some measurements. My goal was to get some measurements before this meeting. And so, you guys help motivate me to do something other than sit around. So I got this baffle done, and the idea with this baffle was there's some the ratio of the left side to the right side is 1 to 1.5, so that the baffle diffraction will kind of cancel a little bit. And so I was just thought, well, let me get a look at what's going on with it. So that's the first. So there's the first measurement just up close, so you can see we're a couple inches from the dome. And so this has a crossover on it at 1 kilohertz and 3,500 hertz. And it's a steep crossover. I had the woofer playing and the tweeter playing, so you'll see some other stuff, but the primary 1 kilohertz to 3,500 hertz there. And so usually you get that close to a driver and it should be an ideally flat response. And this has got a big hiccup here at 2,500 hertz. So I suspect that is the reflection from the dome to the back of it, perhaps. The motor structure. It comes out to being, if you had a 2.7 inch to a reflection, that would give you that. So that would be about whatever.
Excuse me.
Yeah, go ahead.
You can determine that. You can be sure if you plot the impedance.
Oh, right. That's a good idea. That's a great idea. Thank you.
You will see the resonance there.
Yeah. And so my suspicion is this is a reflection off of the metal plate, the center of the motor, right? Which would be back an inch, so it's about 1.5 inches back and 1.5 inches forwards again, gets you to 2.7 inches. That would possibly be what's happening. The other possibility is it could be the lip of the waveguide, because there is a waveguide on this dude.
Yeah, those mids are very well regarded and used in very expensive speakers. So it should be something that you can fix.
Yeah, and so I imagine it's because I'm so close. It could be actually right off the wall of the waveguide. After I look at it now, sound bounce,
I think
right?
you're right.
I guess the question, Dana, is do you see that if you do a measurement from further away? Right?
Let's do that.
Does that repeat if you're out to, at a
Yeah. So my first thought was, oh, is it bouncing between my microphones? So I did the microphone angled, and I got a little difference. So I still have. So that was kind of fun to see. And then what I was investigating to begin with was I wanted to see how much illumination there was at the lip of my waveguide. So when I'm designing the waveguide, I know if it matters or not at the frequency. So I took a measurement there. I screwed up. I didn't show the plot for that one. Oh wait, I did do the plot. Here is the plot. So what I did was I did these two measurements. I did this one, and then I did the second one spaced identically so that the sound levels would be the same. And then I plotted them together. And so this is the top line is the straight out, and then the lower line is the one at the edge of the baffle. And so you can see that this response rolls off. So you're not getting a bunch of energy here at the higher frequencies at that edge of the baffle. It's down, well, these are 5 dB, I think, steps. But so I was, the baffle, so where's my baffle starts to cause trouble on this thing? Well, actually, so the baffle step is around 913.50 is where the what would you call it? Where the diffraction causes its first dip. So it is going to be important. That's actually where there's quite a bit of energy still. So I may want to make the baffle narrower or wider to move that. But so that was my first thought. And then I backed up. So this is where you'd expect if it was, if the up close measurement versus the farther field here. And so in this measurement, there is still something going on at 2,500 hertz. So it's hard. I mean, you got the rest of the.
The other thing that you can do is to take the frequency of that peak and calculate the wavelength, and then relate the wavelength to the size of the.
Yeah, so it's 2.7 inches. Gives you 2.7 inches. Gives you
sorry, I'm on the metric system.
I was gonna say I've got it metric too. 68 millimeters.
So that should be in the 3K range.
Yeah, so it's the 25. Yeah, it's the 2,500 hertz, I think. So yeah, I haven't had time. I took these measures right before the meeting, so I haven't had time to really think them through. But so that's kind of the things I'm going to start looking at.
Can I ask a question?
Yes, please.
Yeah, when you have your, I guess it's a waveguide on a dome mid-range, right?
Yes.
Okay. What if you had a curve on that instead of just a flat surface running at what, 45 degrees or whatever?
Yeah, I was wondering about that too. So that's something I got to investigate, whether I want to put kind of a donut, a half whatever, an extra flange on there to round that out. And when in the speakers people have been building with these, they don't do that, but I could certainly add that.
Yeah.
Dana?
Yes.
I mean, just as an experiment, do you have any somewhat heavy like felt that you could put a ring around and see if that kills that?
Yeah, I would need quite a bit because the frequency. Yeah, I have to get it thick enough so it would affect the 2,500 hertz range. So maybe
or maybe space it out off the baffle a little bit to get that distance.
Yeah, that'd be fun to do. I'll have to try that.
What is the diameter of that dome?
So that's a 3-inch dome.
Close to 2.7.
And
I
then,
wonder
yeah,
if it's coming from the interface between the edge of the dome and the edge of the
oh yeah. I mean,
blade guy, right down in that crevice there, that
Yeah.
corner.
yeah, it'll be interesting to kind of investigate, but it almost looks like a pure reflection, you know, that
Oh, yeah.
characteristic where it rises and then falls is really what you see if you get a single reflection off a surface.
Okay.
So that it could be this, what, you know, this edge, or yeah, so it'll be interesting to kind of, it's easy to compensate for, but of course it'll be different as you go off axis versus straight ahead. This measurement I did, I rotated relative to my room because I was, other measurements, you know, I was going, the wall was going to have a reflection potentially get into the measurement. This one I rotated it.
I am not familiar with ARTA, that I saw that is what you are using to measure. Can you see the impulse response?
Yes, I can.
Because the impulse will show if there is some reflection.
Right.
Yes.
It should show up really clearly. I don't have it ready to show it today, but I'll have maybe next
I think
time.
the other thing my understanding of how to interpret some measurements, Dana, they talk about, you know, comparing your on-axis response to your listening window.
Uh-huh.
The listening window, you usually average, you know, on-axis plus or minus 5 or 10 vertically.
Yeah.
And then like, you know, 0, 10, and 20 horizontally.
Right.
You average like 7 different measurements together. And I think what they tell you about that is if you're in that kind of listening window area and you average those together, if you have little peaks and dips and stuff that vary from position to position, those are probably diffraction related things.
Yeah.
If you have a peak or a dip that tracks all the way through it, that's generally a response related thing.
Got it.
If you average all those together and you compare the average to the individual measurements, you can sort of tell what might be in the driver in terms of resonance in it versus things that are different diffraction artifacts from different places in space.
Yeah, that's cool.
That's supposed to be a way of telling if it's something happening inside the driver that's causing it, or if it's related to the baffle and things.
Yeah, couldn't he do a single pulse and see if it responds the same way?
Yeah, that's what Anibal was talking about. So I have that. I actually have that measurement. I just don't have a way to put it on the screen at the moment.
But even with that, a diffraction artifact will look like a reflection, and you can't tell if that reflection is from diffraction or if it's from something inside the driver.
The trick is finding the source of it, and that idea of, if it's 2.7 inches, there's a couple of ways 2.7 inches shows up in this setup at the moment. Yeah. So then I ran, this is my favorite thing I came up with. This is my standard distance board. So when I make all my measurements, I use this to get the mic the same distance away when I'm doing my crossovers, so the phase works. But and then I did the tweeter. So this is the measurement of the tweeter. It actually looks pretty good, I think. That's and then off axis, I did the tweeters, and on axis and compared those. And so you could see the on axis and the off axis has got quite a dip. So anyway, that was kind of what I got done here in the last this morning, basically. So
how's it?
Well, it sounds great. I mean, when I used the mini DSP and set it up with steep crossovers, and then I just used the crossover frequencies that this Tetra designer used, which is 1 kilohertz and 3,500 hertz, and then I put it on my 12-inch woofer box. So it's got the same driver complement. He had a 12-inch woofer, and then these 2 drivers. He had, I think, a different woofer than I have, but my woofer plays to a kilohertz pretty good. And it's very clear sounding, surprisingly clear. And the crossover frequencies are pretty high. So it is really amazing when you switch the different drivers on and off to see how high, kilohertz and up going into that mid-range. There's very little, content. It's all the harmonics really that go in there. None of the fundamentals of most. the highest female vocal note is what, 1100 hertz, something like that. So yeah.
Well, I really like the dome mid range that David put in his big uglies a few years back.
Yeah.
I always like the sound of that speaker with the dome mid range. That was Morel, I think, dome mid range that he used in that.
Right.
And it was a nice, really nice sounding speaker. I really liked it a lot.
Yeah, that was a MDM 55 Morel.
Yeah.
Yeah.
And I've got a question.
Yes.
What computer program are you using to make those graphs?
So that was ARTA, ARTA. Yep. So I paid for it. You can.
Is that the free one?
Yeah, you can use it for free. If you use it for free, you can't directly save your impulse response files. You can save the plots, copy paste and save plots and do like what I did there. I just took, those are just actual photographs of my computer screen because it was real quick to get a photo. I like to have a photo of the setup, a photo of the graph, so I can review really quickly, document really quickly about what I did. But I saved digitally, the files for more analysis later. But yeah, it's free.
I think ARTA it's like about $100, and it comes with 3 different programs, and the ARTA user's manual is probably worth $100.
Oh, it's amazing.
The guy that wrote it, it actually does tell you how to do some things, which I've got software where the user manual doesn't tell you how to actually do anything. It does tell you how to do some things, but he's got really good, clear theory behind a lot of it too. He shows you the math and in a very much clearer fashion than I've seen elsewhere. It's pretty cool software. I don't use as much as I could.
Thank you very much. Appreciate it.
Yeah. Yeah. Anybody else got something they want to yak about? We're ready.
We should let excuse me. Should let Rene talk about what the stuff he's done for me. My Dynaco amp died, and so I took it to him, and then he convinced me. He says, "Well, I got this one fixed. What about your other one?" So then I took that one to him, and so he did a lot of work.
Let's see. Is he still on? Yeah, there he is. He's muted. You're on mute, Rene. You care to talk to us?
Yeah, I've been doing a lot of 35-watt stereo amplifier repairs lately. First the Jolita, and then 2 of the Dyna Stereo 70s, for Dana. So it's amazing, that those things definitely have paid their way over the years. I mean, how old is that amp? Let's see, 60 years old. I mean, yeah, it's interesting. I was just going through some old AudioCraft magazines from the 50s, and looking at the Dyna ads, seeing as they brought on each of the different lines and so on, and then selling the transformers. And you could buy the transformers for those for like $20 back then. For output transformers, kind of nice.
Very good.
I've often said, well, yeah, they are. They're amazing. Okay, and yeah. So anyway, all designed by David Hafler. But yeah, amps are pretty good. I mean, they're certainly showing their age. Dana's amps are certainly showing their age, and could use a lot of what they call TLC. But it isn't worth him to have me doing that. He should do that. He should go and replace all the tube sockets, and the wiring and all those things that, take a lot of time. But would be worth doing, because as long as the transformers are still good, at least they were in one of his amps. He has to replace the power transformer in one of them. And there are a couple of people selling replacement transformers, which are significantly more conservatively rated than the original Dyna transformer. The original Dyna transformer had, I think, 100-watt power transformer that was cooking along at 240 watts. So I give it back to Dana. It's if you look inside, it's kind of charred. It's turned black inside. So it's not surprising that the primary shorted out at some point. So yeah, so other than beefing up the power transformer and replacing tube sockets, that's still a pretty good amp. And I know Dana's going. He's one of the amps has an original driver board, and this the first one has a somebody else's, and I'm not familiar with it. It uses the EF86 pentode. And a dual triode 12LU7, okay, for the driver part, which is sort of taking the original tube, which is a 7199, which is pretty hard to find these days. Which it was a triode pentode, dual triode pentode tube. Very, efficient design. I mean, it's got a pentode with a lot of gain driving a split mode phase inverter in the triode part. Very simple. So anyway, the mod board that Dana has, the first one, they just took and replaced the single tube with a separate pentode, a very good pentode, and then a dual triode to serve the two sides. But interesting enough, and then I guess Joe Curcio is still selling a board that uses all triodes, uses a 12AX7, I think, in a kind of a what do you call it? A long tail pair driving the split load phase inverter. So I went and I dug up. I have a board that was designed by Curcio years ago that was advertised in Audio Amateur. I'm still in my files. I pulled it out and looked at it, and it's a totally different design. He's got just a differential cascode pair. So there's four 12AX7, or no, four 6DJ8s that it uses. It's a totally different design. So I guess he changed his philosophy somewhere over the years. Anyway, it's there. I was thinking of wiring it up and just seeing how well it performed, kind of distortion, so on. But he must have not liked it. The other didn't like 6DJ8s, so went back to the 12AX7s or 12AU7s, which are anyway. So yeah, so there's still more work to do. But I'll replace the power transformer for Dana when he gets the replacement unit from. Did you order it from Triode?
I did. So it's they sent me an email that said, "Hey, it's only a month out. Order one now."
Yep,
so I went ahead and ordered it. And he said the original one was $20, so the new one was $200 plus shipping.
Good.
So,
Yeah. Well, yeah, the shipping will cost you a bit. It's gonna be fairly heavy, but yeah, that'll be good.
So I was surprised. Because you use the Hammond, which has a lower voltage, but it still sounds really good.
Yeah, that transformer actually. That was a transformer designed by. Sorry, and age is creeping up with me. Trying to think of the guitar amplifier people that Mackie bought. Anyway,
Marshall.
It was for a 50. Huh?
Was it Marshall amplifier?
No, it's the one that was in St. Louis. God. Anyway, I'll remember it at some point. As soon as this program's over, I'll remember it. Anyway, that was used in a 50 watt. I think with push-pull 6L6 pentodes amplifier. Has a lower voltage than the Dynaco. The Dynaco ran very high plate voltages. Not a bad idea. Sound great, but it's just kind of pushing everything. Anyway, this had a lower voltage, but at least I figured I could adapt it. It fit in the same hole, and it was a higher powered transformer than the original Dynaco. So I just told Dana, well, I have the transformer, I can put it in, and if you like it, we can, I'll sell it to you. If not, I'll just pull it out when you get the new one and put the new one in. So that's the plan. Get back to the original transformer. So we'll see. So that's what I've been doing. I'm also working. now that those projects are out of the way, I'm working on an amplifier for Bud. Turns out he had some output transformers and power transformers that he wound a long time ago for a 300B, push-pull 300B amp. So I'm working on putting that together for him at this point. So just keeping me busy.
Do you still have those monoblock amps that you had that were like 8 watts that I borrowed from you that one time? That somebody gave to the club, or you remember the little tiny monoblocks?
No.
Around your garage, and you fiddle with them a little bit.
Oh.
They were like 4 watts, and you turn them into 8 watts and clean them up a little bit because they were a little noisy.
No, I don't have any of that stuff. Yeah, it's gone, I think. Right.
You sold that to somebody?
Yeah, somebody took it. I forget who. Terry, did you take that one? I don't remember. There were a couple of them. That was from, yeah, again, I can't remember his name, but he was at Pacific Northwest Audio Valley, a society guy, and he'd moved to a smaller apartment, so he gave the club the DIY club, he gave him a whole bunch of stuff.
Yeah.
Some of it was pretty good. Anyway. Yeah. So no, I don't have any.
So
but,
in
the
in the background there on your, what exactly is that?
It's a headphone amp.
A headphone amp, okay.
Yeah, it's designed to drive 300 ohm headphones. So 300 to 600 ohm headphones, and I had a lot of 6DJ8s from the Distorvic, left over from the Distorvic project. So I just decided to build it's a push-pull totem pole output stage with 4 parallel 6DJ8s. So puts out a fair amount of current. It actually can drive 50 ohms, but it sounds better at 300. And the power supply.
300 ohm headphones usually do sound the best.
Well, I'm not sure. There were people who will argue that it's the headphones that sound the best are the ones they spent the most money on. And I guess you could spend a lot of money on headphones these days. So.
Well, I guess so. Yeah.
All right.
So
anyway,
there's an amp that Storvik designed in 71 to 73 that I saw on the internet, and they have the full schematics for it. And a lot of saying it might be one of the best amps he ever designed. It's a 350 watt tube amp. I took down the number somewhere downstairs of the website. Share
the MC350, right? Yeah.
Yeah. I think, yeah.
Yeah, that's a monster.
Yeah.
Well, that was the prototype. That was the prototype for the amp that he did. That you listened to, the ones that I had built up.
Okay.
Yeah, he basically took the same approach, because that one, I think he experimented. He used the horizontal output tubes in that amplifier and push-pull parallel, lots of them, and they're capable of a very high current, much higher than the usual audio file, beam tubes that like the 6550s and the EL34s. The horizontal output tubes were designed to deliver a very high peak current into the field coils to produce the sweep. Remember cathode ray tubes? Well, they were the ones that were magnetically deflected, needed to have a fairly high current into the field coils to get the sweep across a large screen. And so these tubes were designed for the 30-inch and 36-inch CRTs. So they're capable of delivering 1.5 amps of cathode current, which is pretty impressive for a small tube. So anyway, he used a bunch of those push-pull parallel in the MC350 to get the 350 watts. But then when he did the Sorvik Alpha 1, he just used a single pair, and the single pair is capable of 150 watts. So again, he's using the Macintosh, what they call unity coupled output transformer,
okay,
which runs the tubes, splits the the output load between the plates and the cathodes of the output tube. So there's advantages and disadvantages to that. The big advantage, of course, is you can reduce the turns ratios, which improves the coupling between the primary and the secondary in the transformer. The disadvantage is that you need to have a very high, you need to have a very large, you need to have very large grid swing because you're driving half of the output voltage. So you have to have grid swings that approach 250 to 300 volts peak, which is a huge amount. So there's challenges to doing that. And so what you gain in the output, you lose a bit in the driver stage. So, but anyway, still sounds pretty good.
Have you been doing any more about what you've been doing? What was the solid state or tube input and solid state output? Is that what you did, or vice versa?
I haven't been doing any more of that. That was done, and I think there were a couple of successful amps. I still have my all solid state 100-watt class A amps monoblocks sitting here.
Wow.
Anyway, they're nice in the winter, keep things warm, but.
Rene, you were talking about plate coupling and cathode coupling too. Recently, I got a present for a friend, Sansui AU 111 is tube, and it has that kind of topology in the output stage. And I will work on that soon. I just cleaning because it was without use for many years and use the same double coupling, but the output tubes are 6L6. I don't know.
Yeah,
if
that's what that's what Macintosh used in the original amplifiers. They used a 6L6. That's what they had back in the 40s. The 6L6 tube. That was the original one he used. He actually used. They were metal tube back in those days too.
Rene, can I
first amps. Huh?
Can I ask a dumb question about tube amps?
Yeah, sure.
I realize as soon as I say tube amps, that really implies stupidity because there's so many different versions of them. But pretty much every tube amp has an output transformer, right? To step down the voltage from the tube section to what you're going to drive your.
Well,
what's the typical output voltage of the tube section going into that output transformer?
Okay, right. The typical good typical in a tube stage with an output transformer, the typical plate voltages are somewhere between 400 and 450 volts. It's the most common.
So they got a pretty massive output swing before you hit that transformer. Huh?
Yeah, because you need. Well, it has to do, of course, with the optimum impedance at the tube.
Right. There's very little output.
The optimum load that the tube can drive to deliver its maximum power. And with most of the output tubes, they're limited to somewhere between 100 and 200 milliamps of peak cathode current. So to get any significant power, you need a load resistance which is up in the 3,000 to 6,000 ohm range. Okay, so that dictates a higher plate voltage in order to get, because you have to get a large voltage swing. So to get the power, I mean, power is voltage times current. So,
right. Is the output typically is it got a DC offset with the AC swing on it, or is it actual AC?
Okay, it's typically two tubes are used in push pull. So the transformer is a center tap, as a push pull type, the center tap. So there's current flowing in both halves of the transformer. Normally they're quiescent current, so there's no net DC flux in the transformer. And one tube turns on and one tube turns off, so the voltage swings back and forth across the entire primary. So that's the way it works. They do make the other popular one, of course, is that's happened now in the last 30 years is the single-ended output type, and that's the case where the transformer runs at a constant DC flux through the primary. Right. So you have to design the transformer with a large air gap, otherwise you saturate the core. And of course, that's a much less efficient design. We're talking about, efficiencies of like 12%. So you put in,
Transformer blocks a DC voltage in that case.
It has a large DC voltage, but also a large current. So it flux in the transformer. So anyway.
Well, thank you. It's interesting to know that. I've always wondered that, and you're the man that knows these things. So thank you.
Yeah, well, I grew up with vacuum tubes and transformers. Ever since I first started tearing into old console radios. I remember discovering one that had push-pull 6v6s. Boy, that was something. Because the typical 5-tube table radio used a 50L6, and a little dinky transformer that usually stuck on the back of the loudspeaker. So anyway, it was that was the typical table radio. And then I think I was given a console radio which had a 6 push-pull 6v6s with 10 watts of output power. That was significant in those days.
And if anybody has a need for them, I have lots of 10 microfarad and 6 microfarad capacitors, non-polarized. So let me know if you need any.
Yeah, the crossover guys need those, right?
What's the
The
voltage?
ones that are still doing passive crossovers.
What's the voltage rating, Baron?
They're rated at 200 volts DC.
Oh.
Hey, I got.
Cool. Thanks.
Yep. Right.
Okay. Well, so I wanted to just introduce two guys that hadn't met in this deal. So Gary Geselshin joined and talked to us a while. And so Gary owns Vanatu, and I just wanted to, the speaker company. And I just wanted to mention that he may not have met Anibal Yusum, who previously is a professional speaker designer. So
okay. I better watch what I say.
I forgot the company you worked for. He designed a number of professional monitors and speakers. So anyway, you guys might like to talk offline sometime.
Okay, hey, I've had a request. I got a phone call during the meeting, and the request was to know how many people have had their flu shot, because we might start having get-togethers with people that have had their vaccination. And I was asked to find out who has had their shots, and I'm one of them. But
I've had one.
Who?
I've had one.
So it looks like Barron's had 2, Renee's had 1. Dana's had, the other Dana's had 2, not me. David Leonard's had 2. Oh, 0. Okay, 0. I personally have had 0. Dana's so 0 for both Danas.
Okay. Okay.
I think I'm another month out before they're going to let me.
Yeah. Well, it's coming along, I guess. So
yeah.
Is that everybody? Baron, have you had one? Oh yeah, your name's here. So I've had it. Baron's had it. Renee's had it. Donna
I haven't.
Just had it. Yeah. And who else?
Dana.
Yeah.
Fuzzy Dana.
Danger. Yeah, there we go.
Oh, there you go.
Yeah. And
I got turned down, so.
How about you, Tim? Tim?
Wow.
No? Okay. Dave Leonard? He hasn't? No? No. John, you're not even there, John. Hello, John. No. Okay. Jay?
0 for me.
No, I haven't had mine. They turned me down.
Oh, and you have? Not?
I haven't.
Okay. Yeah, John, you haven't had it either?
No, probably doesn't matter. I'm 300 miles away.
Oh, we're double safe then.
That's pretty good spacing.
Yeah, it is. It is.
I've had the flu.
Yeah.
But I haven't
No,
had
I don't know. I mean, nobody knows much about this stuff, and I'm one of them.
Yeah.
But there was talk about maybe reconstituting at least partial meetings and where people can get together and evidently be televised as well, I suppose. It would
Sure.
all
We
be
could always do
fair.
vaccinated people inside and the rest of us outside, far away.
Well, on a nice day, that wouldn't necessarily be a bad thing, would it?
Yeah, I know. Just we'd stand out there in the rain.
Yeah. No, I'm thinking more about the girls in the bikinis strolling by and stuff, but yeah.
We could all go, those of us without the shot could meet at some pub and sit out on their outdoor porch.
Yeah.
There you go. I like it.
Call in there.
I like that idea too. Yeah.
I have one little tiny thing to share. I bought myself a toy this week. It's a picoscope. So it's a USB connected software-based 50 megahertz oscilloscope with a built-in arbitrary wave generator.
Beautiful. Wow.
And they make more powerful versions up to a couple $1,000s. This one was like $349 or something.
Yeah.
It's two channel scope, and the saw I haven't even hooked it up to the laptop yet, so I have no experience using it. But some of the guys on Audio Karma, there's guys out there that they're able to make frequency response and distortion plots for their amps, out to like 100 kilohertz or so, and so they're using them to test tube amps and get a read on what their feedback tuning and other kinds of issues are. So I thought it'd be fun to try.
You need to be careful with the probes, because the problem of the USB scopes is that they don't have an input attenuator like a conventional scope. So you will need to make an attenuator if you want to check.
Yeah, it's got a plus and minus 20 volt peak max on the input.
Yeah. That's what I was trying to say.
Mm-hmm. Yeah. So you'll need an input conditioning amplifier.
Yep.
Right.
So you could go on Craigslist and get an old, scope, and it's just borrow the front end.
Well, I think most of the guys just use them across the speaker terminals to see what the whole amp, not hooking them up into the high voltage sections.
Got it.
Yeah.
Yeah, that's cool. I've always wanted one of those, and I ended up getting the Rigol, just the regular scope, but it's got kind of, you got the limited resolution screen and kind of limited features.
I have a regular tech scope, which is I think rated for 300 volts input, so I can use that for other things.
I always wanted to have one of the Pico scopes that's got the 16-bit resolution and 4 channels, but they're pushing $1,500, and I'm too.
Yeah, they get kind of expensive.
Yeah.
Right.
Oh yeah. Well, you want to go 16 bits, and then they probably go 20 megahertz or something, or who knows, maybe faster. It gets expensive.
They still have a pretty high bandwidth rating on some of their 16-bit scopes.
Yeah. So all the money goes into that A to D converter. Yeah, well, that's neat. Well, it'll be interesting to hear how you like it in the next month.
I'll have to get it hooked up and give it a go.
There you go. We'll put some pressure on you.
Yeah, we'll expect a full report next month.
John?
Yeah.
Do they have electricity over in Spokane yet?
I mean, still, not yet. Still.
Oh, still. Okay.
Right.
I'm not gonna say the response that deserves.
Yeah.
The answer is yes, Terry, and all the plugins are in the outhouse. So.
Woo! Get a little east-west.
Yeah. Oh,
yeah, that's right. Oh, I love it. Anybody else have some goodness to share, or we're getting here close to 2 hours? We'll call it a day here pretty soon. But
okay.
Yeah. Anybody else?
Just what you and I talked about the other day. Which,
oh yeah, you want to? Yeah, if you want to talk about that, go for it. That'd be cool.
I don't know. I'm not sure how to describe it in a rational manner. So
yeah,
I've spent years on really basic things that I still don't understand, which is kind of you know, hurtful to my ego because, geez, you think I figured it out by now. But, you know, trying to look at how do you optimize a essentially a ported speaker system. You know, our Vanna speakers are little and we try to get good bass out of them. And the question has always been, well, what is the best that you can theoretically do? And, you know, the systems equations are complicated enough that I can't look at them and just automatically say, well, this is the best you can do. So I've been trying to work on that for years. And I kind of went back and I looked at the sixth. So if anybody knows what a sixth order system is, you basically take a normal ported speaker is considered to be a fourth order system. And you put a filter in front of it to filter out the low frequencies and maybe, you know, add a hump to the response if you want. And you can get a higher order system that has lower bass and, you know, better output than a ported system. And it's got better immunity to real low frequency stuff because you filter that away. So that was, this idea has been around for a very long time. Teal's original paper written in 1960, he, you know, went into detail on it back then. So it's not a new concept or anything, but I spent some time going back and look at that and saying, you know, what's the most you can get out of one of these systems for a given Xmax of a driver? Because that's kind of what you pay the most for. Your system is driver displacement or driver volume displacement. Yeah. And I found a sort of a surprising thing. You can relate if you say that you want, if you constrain the answer to, I want a sixth order Butterworth response, which is a very specific mathematical thing. If you say that's the response I want, all you have to know is the driver resonant, or the system F3 and the volume displacement, and you can automatically specify what the maximum SPL you're going to get out of the system is. Those two or three things define the maximum sound pressure you can get out of the system. And you'll find that doesn't change, and the displacement shape of the driver does not change when you change the box size or when you change the driver parameters. You can, in theory, you can use virtually any driver with any resonant frequency or any EQ, and you can equalize it to the point where they all end up in the exact same place. So if you say that you want that response and you want it to have the maximum output, that defines a set that very, very quickly, nothing else matters. And here's how you have to do it. And I think that answers the question of what's best, because it very quickly you arrive at, well, this is, everything looks the same, and here's what it looks like when it's at its best. And that kind of sets, I think, the high water mark for what you could do in a design. You can always do worse than that. Just because that's the high water mark doesn't mean you're gonna realize that with any design that you do. But I think that actually sets sort of a theoretical, here's the best damn thing you can do. And maybe other people that have spent years on speaker design knew this a very, very long time ago, but I didn't. And I think I know that now. This is only a few days old, the findings, but I sort of think I know that. I didn't used to. So
yeah.
Can I suggest something? And that is that you talk to Dan Wiggins.
I talk to him on occasion. We use his patent, so I haven't talked to him in a couple of years, but
yeah, well, he can be contacted. I talk to him every once in a while, but you know, he did an awful lot of work on that stuff, and he may not have written it all down, but he knows that stuff pretty well. You might want to just tap him on the shoulder.
His old business partner, David Hires, is around too, and I know him a little bit. He and I've got together a couple times. So
yeah, I saw Dave here just a couple of years ago. It was the first time in a long, long time, but you know.
Yeah, that's a good idea. Anyway, that was kind of an interesting thing to me, that in theory, basically, as you change the driver parameters in the box size, you will find radically different power levels it takes to drive the system. Yeah. And you know, in theory, you can use a small box, but in reality, you'd never be able to fit a port in a lot of the things. So it doesn't say that all things are physically possible. All things are theoretically possible. When you start looking at what's theoretically or what's practically possible and makes a good design, it narrows it down in a big hurry. And that's why if you want a ported system that plays low bass and plays loud, it's going to have a big damn driver and a big damn port in a big box, because you got to fit the port.
Yeah.
But this whole logic puts an upper bound on what's the best you can get out of it. And the transparent one, Encore, I haven't gone back and looked at it real close, but I think it's I think it's about 4 dB less than the best you can do on output. There are things in the actual design that says, you know, well, why aren't you as good as what's theoretically possible? And that's pretty good. It used to be worse than that. It got better on the last iteration. I'm gonna see if it can get better again in the next iteration. So
Yeah. So do you think what did you run out of like power capability for the voice coil, or what do you think bounded it?
you don't have as much Xmax out of the passive radiator as you'd like to.
Oh, there you go. Okay, I remember you mentioned that. Yeah.
You have real losses in the system. You got a box queue and you got losses in the passive radiator and stuff that aren't in the ideal case. So
Sure.
there are things in the physical world that just limit you a little bit.
They get in the way a little. Yeah, but 4
And
dBs.
then if you don't drive it properly, which is a big deal. I mean, if your arbitrary waveform essentially or frequency response that you're driving it with isn't optimized for what you're trying to do, you can get something different, right?
Sure.
So,
yeah.
If I had
what ratio are you using for your passive radiator versus the driving radiator? 2 to 1, 1.5 to 1?
Well, in the Manitou stuff, they're the same size, and it's just a packaging issue of fitting the stupid thing.
Yeah.
So we claim we got about a 3mm Xmax on our little guy and about a 5mm Xmax on our big one.
Yeah.
And the assumption is the PRs need to put out about twice that.
Yeah.
And, I did a stupid amount of work last year on the non-linearities of our drivers and passive radiators, trying to understand what limited the output of the system. Because I always thought the PR was probably limiting us kind of badly. And what I found after, I mean, really way more hours than a human being should spend on such things, was that the passive radiator, while it's traveling a lot further than you might think it should, isn't actually the big source of distortion. It's actually the woofer traveling at a far lower. We have pretty well designed woofers with good linear, BL curves and stuff compared to most. But still, when you start getting the thing out near its Xmaxes, it is the source of most of the distortion.
Yeah.
So the passive radiator, much less so. And you can separate those two things. When you measure them, you can't measure them separately because they're so physically close together.
Yeah.
But in the model world, you can see which one's generating the distortion, and that tends to seem to be the case. So
Yeah.
Anyway,
That's cool.
sorry.
Yeah, that's awesome. Thanks for sharing that. Yeah.
But that whole notion that there's something that kind of sets an upper bound on what's the best you can do, and man, you have to know very little. You just only got to know a few things. And it says, well, given those few things, here's the best you could do.
Yeah.
Which is kind of cool. So
that is.
Okay.
Fantastic.
Well, thanks for showing up, Gary. It's good seeing you again.
Yeah, it's nice to see all you guys. So
yeah,
it's been a while, and hopefully we will see each other. I'm in that group that becomes eligible for the vaccine in the next couple of weeks, and so
Okay, good.
It shouldn't be too long till most of us are there. So.
Yeah.
Yeah, excellent.
Yeah, it'll be a little bit longer than that, and there won't be any of us anymore. Oh shoot!
Let's hope it's a lot longer than that.
Time goes real fast. Yeah.
Well, neat. Well, I guess we'll call it a day. Yeah. And thanks everybody. I enjoyed seeing you all.
Thanks. Real good.
All
Thank
right.
you.
Enjoy the rest of your weekend.
Bye.
Take care, guys. See you.
Be good. Okay.
Bye.
All right.